Physics 2211, Lab 5, Physics of a golf ball on a hard surface. The initial parameters for this experiment was the golf ball's mass of 45 grams, the golf ball's initial height of 1.463 meters, its initial velocity of 0 meters per second, and the ball's diameter of 4.267 centimeters. Principles at work during this experiment was the energy principle, where potential energy equals mass times gravity times height, and the kinetic energy equals 1/2 mv squared. The video I recorded for this was recorded. As you can see, as the ball falls, it is outputting in this graph right here. It has very smooth ridges and troughs. At the end of this video, I'm going to show the outputted graph in Excel, just to make it a little bit larger and easier to see. Okay, so in my Excel file, as you can see here, the graph outputted had very smooth bumps as it went along. This was very helpful in visualizing the amount of energy lost during each of the bounces. In my code, I used a modified Lab 2 code as the base for it. The one place I had to modify it the most was I had to add an extra line causing the ball to rebound. However, I was not able to get this ball to rebound properly, as the ball went above the initial trajectory and actually broke through the floor. I'm not exactly sure how that happened, but as far as the ball's maximum velocity, it was supposed to be, in ideal conditions, 5.355 meters per second. However, I calculated it out to be 5.062 meters per second. The only forces acting upon it during this time was gravity and the air resistance. So in the opposite direction of gravity was air resistance, so I calculated it out to be 0.0019 joules lost to air resistance. And what effects do air resistance and thermal energy have on the actual experiment? I found that thermal energy was the largest contributor to how much energy was lost on the bounce. As you can tell, the 0.0019 joules lost to air resistance is very small, and these losses of energy are what cause the ball not to rebound as high as the initial drop. And how much energy is lost on the bounce? I found that 78.04% of the initial force was retained from the peak to the trough. And that's it for Lab 5. Thank you for watching.